of just algebraic equations. So specifically exponential and log equations, which we've done earlier this year, just kind of some of the more simple equations where there were some nice little tricks to them. But today, some will be long, some will be short, and we'll just kind of go through as many as we can. So learning target 10, solve big old exponential equations. And number 11, solve logarithmic equations. And each one, kind of like once you see the trick to it, or at least how to get started, the rest kind of just falls into place. So it really is a matter of you just need to get the repetitions in, practice, see some of the things that commonly pop up, and you should be good to go. So here we go. Solve 7 to the x equals 12. Well, for this particular one, we've seen something like this before. We could turn this into a log. Like if maybe we could do a common base. That might be a nice thing to do, but I don't think that's going to happen. And so what we can do is we can say, this is the same thing as log base 7 of 12 equals x. And sure enough, this would be something that we could just go ahead and use the change of base theorem to solve. So log of 12 divided by the log of 7. And we wind up with something that we probably should have a pretty good idea. We know it's going to be in between 1 and 2. 7 to the first is 7. 7 to the second is 49. So it's probably going to be closer to 1 than it is to 2. And sure enough, when we check this out on our calculator, we get about 1.277. So this one right here is a nice little easy start. This one appears to not be all that much different than maybe some of the other ones. But like if I could make this 3 to the x plus 2, man, that would be super easy. These just cancel out. But no, that's just not the case. So here's how we're going to start this off. We're going to actually go ahead and just take the natural log of both sides. So we say the natural log of 3 to the 2x minus 1 equals the natural log of 0.4 to the x plus 2. And at this point, anytime you've got like logs or natural logs with the exponent, you can go ahead and just bring that out in front. That was one of the properties that we talked about. So this is 2x minus 1 times natural log of 3 equals x plus 2 times the natural log of 0.4. At this point, we're going to go ahead and kind of use the distributive property with our natural log since we got multiple terms in here. So we'll do that with both of these. And so we wind up with 2x natural log of 3 and then minus just natural log of 3 times negative 1. Then over here, x times natural log of 0.4 would just be x natural log of 0.4, and then 2, so plus 2 natural log of 0.4. All right, let's see. At this point, again, don't lose sight of our mission. We want to ultimately solve for x. So what I'm going to do is I'm going to put all of the x's on one side. And so when I do that, I would have 2x natural log of 3. So I'm going to add the natural log of 3 and put it on this side. And I'm going to subtract x natural log of 0.4 to put it on this side. So minus x natural log of 0.4 equals positive natural log of 3 plus 2 natural log of 0.4. So at this point, hey, at least we've got all of our x's on one side of the equation. And I've got two terms. I've got an x in each term, and so I can factor out that x. So I got x, and then I'd have 2 natural log of 3 minus natural log of 4. So that's what the left-hand side looks like. The right-hand side is just going to be the same. And at this point, natural log of 3 plus 2 natural log of 0.4. At this point, if I want to get x by itself, I'm just going to go ahead and divide both sides by this 2 natural log of, not to the third, natural log of 3 minus natural log of 4. So 2 natural log of 3 minus natural log of, I guess is 0.4. And at this point, I've got x by itself. And you can do a bunch of stuff here, but I think all of this just winds up being able to be entered into your calculator. And so you go ahead and just make sure you kind of put parentheses around this when you do this in your calculator, and you'll wind up with approximately negative 0.236. All right, so that's kind of a big, nasty one, not nearly as nice as we would like to see that we saw earlier in the chapter, but this is the progression. All right, so working with e a little bit here. This one, you've got e to the x squared equals 200. So again, one of our strategies here would just be to take the natural log of both sides. Equals natural log of 200. And when we do this, again, we have an exponent with a log, and so we can bring that down in front using our power property. So we've got x squared natural log of e equals the natural log of 200. Well, the natural log is the inverse of e, which is something that we've talked about. And so this is going to cancel this out. Just like adding 1 to negative 1 would cancel it, make 0. And so what we wind up with is x squared equals the natural log of 200. And we take the square root of both sides, and x is equal to positive negative natural log of 200, which boils down to something you can easily do in your calculator. And so we'll say positive, negative, and I believe the answer is approximately, not the square root of, is just 2.302. All right. So that one's not so bad, but again, using this trick of just taking the natural log of both sides. All right, okay, with this one here, we've got all of these e's, and so what we can do is, remember, when we're multiplying exponents with the same base, and these definitely both have the same base, e, what you're going to do is you're going to add them together. And so this would be the same thing as saying e to the 2x plus 1 plus negative 4x, or minus 4x. And, well, when I simplify this exponent, 2x minus 4x is negative 2x, so negative 2x plus 1 equals 3e. And if I go ahead and divide both of these sides by e, it's kind of a interesting little trick. This e would be the same thing as like e to the 1, and so when I'm dividing with the same base, it's like I'm subtracting. So if I had, at this point, I'm subtracting the exponents. It's like I say e to the negative 2x plus 1 minus 1 equals 3 when these cancel out. And so I wind up with e to the negative 2x equals 3. And at this point, we get to a place where, man, to get rid of this e, let's take the natural log of both sides. So natural log of e to the negative 2x equals a natural log of 3. And again, I've got this power rule, so I can bring this out in front. So I got negative 2x times the natural log of e equals the natural log of 3. The natural log of e cancels things out, and that's nice because now I just have negative 2x equals the natural log of 3. And, well, this isn't so bad. I'm going to divide both sides by negative 2. And I wind up with x equals, and again, you can do all of this on your calculator, and it looks like it's about negative 0.55. All right, over here, we've got what appears to be a quadratic of sorts. Uh, so here's how we might go about doing this one. Um, so I'm going to break this up, this first one, into e to the x squared minus 4 e to the x plus 3 equals 0. And notice that I've got an e to the x in this term, and I've got an e to the x in this term. You're familiar with the method of substitution, solving using substitution. So I'm going to say that u is equal to e to the x. And I'm going to replace e to the x with u. And so that would leave me with u squared minus 4u plus 3 equals 0. And hopefully this is a little easier, simpler thing to factor. And sure enough, we can factor it. We get u, and then minus 3 and 1. And so u is going to either equal 3 or positive 1. Now don't forget that we actually need to plug this back in to solve for x. Solving for u is not what we want to do ultimately. So u either equals 3, in which case 3 would equal e to the x, or I get 1 equals e to the x. Well, if we're going to solve for x here, then we can just go ahead and use our properties here to get rid of the e. So we take the natural log of 3, and then the natural log of e to the x. And so I can bring the power rule back down here, and so I get x times the natural log of e equals the natural log of 3. And the natural log of e is going to cancel out. So I get x equals the natural log of 3, which is approximately 1.01. And then the other one here, well, e to the x equals 1. And if you really want to go through the whole process here, you can do that. You can take the natural log of 1 and natural log of e to the x, which means we got x times natural log of e. So these cancel out. And over here we have the natural log of 1. So x equals the natural log of 1. But remember, again, don't ever lose sight of what these natural logs really are. It's really just log base e of 1 equals what? So e to the what equals 1? Well, natural log of 1. Well, e to the 0 equals 1. And so we'll say x equals 0. All right, moving on to a few new examples. A couple of these are shorter. We got 7 times the natural log of x equals 28. Let's just go ahead and try to get x by itself. So let's divide both sides by 7. And so now I've got natural log of x equals 4. And, well, the natural log of x, remember that's just going to be log base e of x equals 4. It's like saying e to the 4th power equals what? Well, e to the 4th power is just something you can do straight on your calculator, and you would wind up with x equals about 54.6. All right, so that's a nice tidy little one if you kind of remember what natural log is. Here we've got natural log of 2 of x cubed minus 19 equals 3. So again, when I've got this whole log thing here, let's turn it into an exponent. The base is 2. I'd put that to the 3rd power equals x cubed minus 19. And, well, let's see, 2 to the 3rd is 8. So I've got x cubed minus 19. I'm willing to bet you guys can do this one just fine. We'll add the 19 to both sides. We get 27 equals x cubed. The way that we get rid of something cubed is to take the cubed root. So we take the cubed root of both sides, and x equals 3. All right, next one. we've got log of x plus 6 minus log of x plus 2 equals the log of x. Well, remember, again, our properties, shifting all these logs around. When I'm subtracting logs, it would be like the same like I was dividing. Dividing and subtracting, subtracting. So I'm going to go backwards and say that this is actually log of x plus 6 divided by x plus 2 equals log of x. And at this point, I've got logs on both sides. And so essentially I can just cancel these out. And I can say x plus 6 over x plus 2 equals x. And at this point, solving for x is not all that challenging. I'm going to multiply both sides by x plus 2. And so these will cancel out, and I just get x plus 6. My fraction is gone, and over here I get x squared plus 2x. It's at this point that I realize, oh, I've got myself a quadratic. So I set it equal to 0 and hope I can factor. So I subtract x from both sides. It leaves me with positive x, and then subtract 6 from both sides. And let's try factoring. We've got x, positive, negative, factors of 6, it would give me positive 1, would be positive 3, and negative 2. So it is factorable, and so my answers here are negative 3 and positive 2. All right, let's wrap this up. We got one more slide. Here, we've got two things that are multiplied together. And we got base 2. So here's another case where let's go ahead and turn this into an exponent and see what we can do with it. We got base 2 to the third power equals, well, this whole thing right here. And that whole thing, if I multiplied it out, FOILed it out, would be 3x squared minus 19x plus 28. And again, it's at this point that I realize it looks like I've got a quadratic. 2q to be 8. So I would subtract 8 from both sides, make it equal to 0, and that would leave me with x squared minus 19x. Subtracting the 8 from over here gives me 20. So positive 20. And, well, gosh, it's let's hope it's factorable. And I do believe it is. So we'd have 3x and x. We would have 2 negatives, and the numbers that work here are 4 and 5. And, well, that means that x is going to have to equal positive 5 or positive 4/3. All right, the last one here. Again, what we're seeing here is we are adding logs, and so maybe we can just go backwards like we did a couple examples ago and multiply them. So it'd be log of 3x plus 2 times x minus 1. These things would all be together, equal to 1. And when I do that, of course, I can go ahead and FOIL these out. So I've got log, and then this would wind up being 3x squared minus x minus 2 equals 1. And here's what we can do. Remember over here, or I guess a couple problems ago, we had logs on both sides, and that allowed me to essentially cancel the logs out. Well, here I've got 1, and 1 is like a convenient number for me because log base 10, remember this is log base 10 since there's nothing written here, log base 10 of 10 equals 1. So what I could do is I could replace this 1 with log of 10, or log base 10 of 10. 1 is equal to log base 10 of 10. So over here, I still have the log of 3x squared minus x minus 2, and then the logs will wind up canceling out. And I have 3x squared minus x minus 2 just equals 10. And now you should be able to solve this one. We can subtract the 10 from both sides to make it equal to 0, so I'd have 3x squared minus x minus 12 equals 0. And then, is this going to be factorable? My gut instinct tells me no, in which case we'd either have to complete the square or do the quadratic formula. So we got 1 plus or minus the square root of negative 1 squared minus 4 times 3 times negative 12 divided by 2 times a, which is 3. I'm sure you guys can go ahead and get all this, but we wind up with 1 plus or minus the square root of 145 divided by 6. And here's the thing, and this is kind of nasty, but if I wind up with 1 minus the square root of 145 divided by 6, my answer winds up being negative, and when I plug that back in here, you can't take the log of a negative number. That doesn't exactly work. So this negative sign right here, that doesn't work. So it's just 1 plus the square root of 145 over 6. All right, well, that's it for solving some of these pretty large logarithmic and exponential equations.